important, and in the perspective of engineering, I really like this question. Two engineering objects are designed as follows for an engineering application. While in performance, this assembly goes through various temperatures, like in the train station, the train railway, for example, they go through various temperatures in the daily life. Calculate the gap between the two objects as a function of temperature. And then, what is the maximum temperature that this assembly can be heated up to? So also there is two thermal expansion coefficient of aluminum and steel, which is given in the question. So I will go to the answer of this question. First of all, I need to explain something here. So for example, you consider you have two objective engineering objects. Do you have any questions? Excuse me. So consider you have two engineering objectives here, one of them with a different material, so therefore they have different properties, different specificities, different thermal expansion coefficient, and this kind of stuff. So just you consider here they exist in the initial gap of 70 centimeters from each other, and the initial length of each, for example, the aluminum is 20 meters and the steel is 5 meters. When the temperature increases, what happens for these two alloys? What do you expect? Expansion. Yes? They will expand. So if there wasn't this gap between them, they will touch and the break and the collapse and explosion and accident and lots of things happen. But there needs to be some kind of gap between these two. When they want to expand, there is some space for them, because each material has a different thermal expansion coefficient. Now the question asks how this gap can be changed based on the temperature, because temperature is one of the important points in the engineering aspect when you consider it. So basically, just you can consider this gap as a x, and then think about it like, for example, in the initial state, it is in the 70 centimeter, it's 0. And when the temperature increases, definitely the gap between these two alloys must decrease. So minus of delta L steel and delta L aluminum. What is the delta L? Is the change of length during the temperature changes. So now you will have a gap formula. Based on the thermal expansion also, this formula is in your lecture note, second lecture note. So there is a relationship between the change of the length, the initial length, thermal expansion coefficient alpha, and change of temperature. So simply by writing the change of length based on the temperature, based on this thermal expansion formula, you can find a relationship between the change of length and the temperature. By replacing each of the change of the length of the steel and aluminum in the formula, you can find the relationship between the X gap between these two alloys and the temperature difference. Now when you have this one, the question asks you, what is the maximum temperature? What is the maximum temperature these two can go up till that temperature? So for answering this question, what is your way? What is your suggestion? You have a very simple formula, so what do you need to do to find this maximum temperature? Yes? You have any answer?